Okay, so let's get started. So in the last class, we talked about how atoms are and how people were able to figure out that atoms have a very dense nucleus and there are electrons around them. But they had little idea of how those electrons are going to be. In fact, initially they didn't even know that there's electron. All they knew was that negative charges hote hain. So then they started doing an experiment. What they did was that they, just like when they were discovering nucleus, तो उनके पास, I told you they had a gun, and that gun basically shot alpha particles. तो alpha particle gold पे उन्होंने फेंका and gold के अंदर से वो गुजर गया, तो that means कि वो ज़्यादातर empty है, and a small portion got repelled, which shows कि उसके अंदर positively charged बड़ी dense सी nucleus है. So from that they figured out कि अच्छा इसमें nucleus होता है and the rest of it is empty. So they used a similar technique to figure out electrons as well. So this time their gun wasn't alpha particles ki gun. They had a very small bullet in there, which is basically the electron. So what they did was they started giving it energy, and they started seeing that when you give a lot of energy to the atom, there are things that come out of it, and those things are negative. And there's a set pattern as to kitni energy deni padti hai for the atoms to start emitting these rays or these particles that they have. Again, I'm talking 120 years ago. उनको कुछ पता नहीं था कि electron कुछ होता है. Today we know that the particles that were coming out, they were electrons. And they had a name for it. Because the moment one atom loses that electron or ejects that electron, so it's no longer an atom, it's ion. And the energy required to become that is called ionization energy. Ionization energy is the energy required to remove an electron. Why were they removing electrons? They were just trying to see कि क्या होता है अगर हम atom को energy दें. That's all they wanted to know. So this is the energy required to remove electron from atoms or ions. So let's say I have a general atom. Let's say I have sodium. I give it a lot of energy. It's going to emit that electron. So ab kya hoga? It will lose one electron. And what will I get? What kind of ion will I get?
Na+1.
Na+1. Yes, very good. And to do this, jitni energy chahiye, we're going to call it a name. Because, you know, every reaction, every process has some delta H there. So iska jo delta H hai na, we're going to call it ionization energy. And because it's the very first electron that we removed, we're going to call it IE1, the first ionization energy from this. So agar main isko define karu na, so first of all, what I need to know is कि देखें उन atoms की आपस में कोई bonding नहीं होनी चाहिए. Because I want to know exactly the energy required to remove electron from the atom. मुझे ये नहीं चाहिए कि मैं energy supply करूं और वो उसकी bonding को तोड़ने में use हो जाए. I don't want that. So to do that, I will first make it a gas. वो कैसे होता है वो बस जैसे मर्जी है, मुझे gas चाहिए. Because I want to know exactly the energy that is required to remove just the electron. I don't want to deal with anything else. So in gaseous form, every atom is for itself. It's independent of every other atom. And there you go. So now I have sodium atoms emitting electrons. And the energy required to do that. And then I also don't want the ions to make any other bonds as well. So this energy, जिसमें उनकी कोई bonds नहीं होती, they're just removing electrons. This energy is called ionization energy. And first ionization energy का मतलब क्या होगा? I will start with atoms and I will end with ions. So if I were to formally define it, the first ionization energy would be the energy required. So the word required tells me a lot about the nature of this energy. What do you think? What's the nature of this energy?
Endothermic.
Endothermic, exactly. Just by looking at it, कि ये required है, I know right away that this is endothermic. I need to supply this energy. To remove, देखें क्या remove किया मैंने? 1 mole of electron remove किया. किस में से किया? From 1 mole gaseous atoms. And what did I end up with? Sodium ions के 1 mole. And sodium is just an example. I could have any other atom in the world. It doesn't matter what kind of atom it is. Like it could be a metal, it could be a non-metal, it could be a metalloid. I don't care. It could be anything. It could be a noble gas. As long as I can emit electrons from it, I'm good to go. So remove a mole of electron, 1 mole gaseous atoms. The energy that I need to achieve this energy is going to be called first ionization energy. Okay, so I've removed one electron. If you want to mention that it will give me one mole positive ions, sure, no problem. Mention that. But the important bit is you're removing electrons, 1 mole of them from 1 mole gaseous atoms. That's the important bit. And it is always endothermic. Why is it endothermic, by the way? Any thoughts? Every time you have to supply energy, that means you're breaking a force. There's a force you're fighting against. In the case of these electrons, they're being pulled by the nucleus. You're fighting that force, the pull from the nucleus. And that is why this is the energy required to break that force. Taki electron free ho and it moves away. Okay, so I now have this. Can I still remove more electrons? Of course I can. So the people that were doing this experiment, they were very curious कि क्या और भी remove हो सकते हैं? So they tried it. So they took this ion, which already had lost an electron. Again, it was gaseous. And now they're going to remove one more electron from this. And this is kind of something that we don't see in O levels. And that's fine. If I remove one more electron from this, what's the charge going to be? Yes, it is positive 2. So here you have it. And this energy, the delta H in this particular reaction, that's going to be called IE2 or second ionization energy. What would it be? Let me define it. So it is again the energy required to remove a mole of electrons, which as you can see, I did. I removed a mole of electrons from 1 mole gaseous positive 1 cation, because I've already lost an electron from all of them. I need the cation to give me the second ionization energy. So the number here is telling me which electron are you removing. So obviously the third one will be removed from this. So the third ionization energy will be from the gaseous positive 2 cations. Compare this one and this one. Which one do you think will be higher? Again, in any reaction, in anything you see in chemistry, a higher energy means a higher force that's going to be broken, that's going to be countered. So let's see. Over here, I had nucleus pulling on these electrons. Now I have a positive ion pulling on these electrons. Clearly, the force of attraction is much stronger. And there are other factors as well, which we'll talk about later. This one is going to be higher. This one's going to be lower. In general, these things do vary sometimes, but in general, we can argue कि ऐसे होता है. There are cases जहाँ पे ऐसा नहीं होता है, but we'll talk about them as well. Okay, so the scientists, they were just playing around. They figured out कि अच्छा energy देते हैं, electron निकलते हैं. Let's keep on doing that. Let's get the second ionization energy, third ionization energy, fourth ionization energy, fifth, sixth, seventh, 8th, 9th, 10th, 11th. No matter how much energy they supplied, they could never get 12th ionization energy for sodium. No matter what they did. जितनी मर्जी ज्यादा एनर्जी सप्लाई करते हैं, जितना मर्जी अच्छा एक्सपेरिमेंट कर लें, हो ही नहीं रहा. So there are two explanations for this. One is that the energy you're supplying is not enough. Maybe if you want to remove the 12th electron from the atom, you need to supply such a high force, such a high energy, कि आपने अभी तक वो achieve ही नहीं की है. But then at the same time, when they tried the same thing with magnesium, 12th हो रहा था. They tried it with aluminum, 12th हो रहा था. They tried it with sulfur, 12th हो रहा था. Sodium के केस में 12 नहीं हो रहा है. 12th ionization energy of sodium was, they were unable to find it. So if 12th is not possible for sodium, and it is possible for the others after this, तो फिर एक explanation है. Sodium atom has 11 electrons. We now know that that is true. जितने protons होते हैं उतने electrons होते हैं, and that is the number of ionization energies you can get. Sure, उनकी value बढ़ती जाती है, but that is the level of energy, that is the number of electrons you can remove from any atom or a mole of atom. So ionization energies are limited by one factor is कि किस तरह से आप किस atom में से कितने electrons remove हो सकते हैं. Okay, ठीक है. अब let's talk about that force of attraction. वो force of attraction जो है ना, वो कहाँ से आ सकती है? From the nucleus. So obviously, if the nucleus has more protons, it's going to pull on the electrons more. And this is what we'll call effective nuclear charge. As I told you, this energy that you're supplying is countering the force of attraction. So force of attraction कहाँ से बढ़ेगी? Effective nuclear charge से. ज़्यादा प्रोटॉन है, ज़्यादा अट्रैक्ट करेंगे. प्रोटॉन्स हैं तो अट्रैक्टर होते हैं, ज़्यादा प्रोटॉन है तो ज़्यादा अट्रैक्शन होती है. एक और चीज भी है, इलेक्ट्रॉन एटम से मूव कर रहा होता है. It's moving around. It's somewhere there around the nucleus in there. So if it is further away, the force is bound to be weaker because this is force of attraction, which is electrostatic force. If you study physics, you might be familiar with the idea of Coulomb's force. So, or Coulomb's law. So that depends on the distance between two things being attracted. So in this case, the distance, because we are removing them from really far away from the atom, we will say it is the radius. Now, of course, in the case of first ionic energy, that is the atomic radius, but in the case of second ionic energy, that is ionic radius. So this radius can be the atomic or this can be the ionic. Basically, this is just telling me how the force varies. And then people got thinking, wait a minute. If I'm removing one electron and there are other electrons in the atom, so shouldn't they be happy? Good riddance. अच्छा है, चले गया. Because electrons absolutely hate other electrons. They can't stand each other. They repel each other all the time with a very vehement hate. बहुत strong force of repulsion होती है उसमें. So this is what we call shielding. Basically, we're saying कि अगर ये nucleus है and there's an electron that is flying around it, and there is another electron somewhere there which is closer to the shell. So अगर ये इसके पास आने की कोशिश करेगा, this one will shield it. ये उसका रास्ता block कर देगा. It will repel it. So the nucleus is being shielded from this electron, the further away wala electron, the electron that's farther out there. So shielding effect. In simple words, effective nuclear charge is attraction of the electron. Radius is all about the attraction of the electron. And shielding up is all about the repulsion from the other electrons. Now, if the radius increases, attraction decreases. And we know ionization energy is there to counter the attraction. So इसका मतलब हुआ, if effective nuclear charge increases, attraction increases, ionization energy will also increase. Simple as that. If the radius increases, attraction decreases. And ionization energy will also decrease. Attraction ही कम होगी है तो मुझे उसको काउंटर करने के लिए force भी कम ही चाहिए, energy भी कम ही चाहिए. And in this case, if the shielding effect increases, then the repulsion increases. And when the repulsion increases, attraction decreases. So ionization energy also decreases. अगर वो attract ही कम कर रहा है उसको, so obviously it's going to make it easier to remove that electron. And there you have it. These are the ways you can think of ionization energy. It is all there to counter the force. जितनी भी energies आप देखोगे ना, जितना भी आप A levels chemistry पढ़ोगे, you have to think in terms of कि positive negative के बीच की attraction repulsion कहाँ पे हो रही है. Repulsion ज़्यादा हो रही है तो attraction कम हो रही है, attraction कम हो रही है, energy required will be less. Attraction ज़्यादा हो रही है, energy required will be higher. And this is the first such case that we are seeing. So clearly ionization energy depends on the electron being further away from the nucleus, the nucleus having a lot of protons, and the other electrons repelling that electron. So that is how they're going to affect it. ठीक है, सब समझ आता है. So the trend is ठीक है, समझ आ रहा है. And then they went crazy, these scientists. वो कर रहे थे ना, and this is all their thought कि अच्छा एटम होता है, उसमें इलेक्ट्रॉन होता है, वो दूर होगा तो आसानी से रिमूव हो जाएगा, पास जाएगा तो मुश्किल से रिमूव होगा. They are doing all of this. बड़े ब्रिलियंट आइडियाज आ रहे हैं और मशीन्स के साथ वो खेल रहे हैं. सो दे डिड इट पेन्सटेकिंगली, बहुत अच्छी मशीन्स के साथ बहुत मेहनत की उन्होंने. एंड दे फाउंड दिस टेबल. Ionization energies first, second, third, fourth of selected elements in kilojoules per mole. I told you that ionization energy is going to be in moles, energy per moles, because one mole में से remove करके standardize कर लेते हैं ना उसको. So they knew these protons. Mass spectrometry से उनको पता लग गया था. उन्होंने ionization energy करना शुरू किया. They saw a couple of things. First of all, they noticed कि हाइड्रोजन में एक प्रोटॉन होता है और उसकी ionization energy भी एक ही होती है. No matter how much energy you give, it never gives you a second electron, which shows it has just one proton and one electron. Helium के पास दो हैं, वो दो ही करता है. Lithium के पास तीन है, वो तीन ही करता है. So clearly, the number of protons and the number of electrons are equal in a neutral atom. That's the first principle that we get from this. Number of protons equals number of electrons. पहली बात जो हमें एटम के बारे में ionization energy से पता लगती है. Okay, समझ आ रही है? They already had the periodic table. वो तो 150 साल से हमारे पास है. They were like, how does this relate to periodic table? Let's see. Periodic table में hydrogen and helium, they're in the first row. So they were like, अच्छा, अगर मैं first row में देखूं, तो the value is increasing. Interesting. If I go like this in the periodic table, the value is increasing. Interesting. They said, does that thing apply to the second one? So in the second row, I have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Let's see. Increase, decrease, ouch. Increase, okay. Increase, slight decrease, increase, increase. And starting here and ending here, a large increase. So apart from these two cases, which I don't know what's happening, these show me an overall increase in the energies from here all the way here. Good. People like simplified versions of things. उनको अच्छा लगता है ट्रेंड्स देखना. So they were like, देखो इनको हम अभी के लिए इग्नोर करते हैं, बाद में इनकी बात करेंगे. ओवरऑल तो ये इंक्रीज ही कर रहा है. अच्छा, लेट्स सी क्या आगे भी ये चलता है. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Let's look at these. From sodium, and wow, increase. So then they were like, अच्छा एक second. What happens in a periodic table? सामने नजर आ रहा है भाई. 11 से 18 तक you are increasing protons. You're increasing the attraction. So ionization energy increase ही करनी चाहिए. And not just that. If the atom is having more protons, तो वो outermost electron को pull भी तो ज्यादा करेगा. So उसका radius same तो नहीं होना चाहिए. Even though they have the same row in the periodic table. By the way, they don't know about shells yet. They have the same row in the periodic table. तो उसका radius कम होना चाहिए. Because protons ज़्यादा हो रहे हैं, उनको pull ज़्यादा कर रहे हैं. So ionization energy across the same period should increase because you're getting more charges, but at the same time, radius is going down, which means attraction is going to increase. So attraction increase करेगी तो ionization energy increase करेगी. Radius बढ़ेगा, attraction decrease करेगी, ionization energy decrease करेगी. So across a period, for the first atoms, radius कम हो रहा है, attraction ज़्यादा हो रही है, ionization energy भी ज़्यादा हो रही है. ये भी ज़्यादा हो रहा है, ये भी ज़्यादा हो रहा है. ionization energy हमारे सामने इस तरह से change हो रही है. They didn't really know about shielding effect at the moment. So across a period उन्हें एक trend नजर आया कि in general the atom becomes smaller, the effective nuclear charge increases, attraction बढ़ रही है, तो automatically they were like कि ionization energy बढ़ रही है. And there you go. Exam में भी ये 3 मार्क का क्वेश्चन पूछ लेता है. Then they were like, okay, ठीक है, मान ली बात. Across a period समझ आ गया. Let's see down a group. So let's start with the atoms with just one electron in the last shell. Just one in the last shell, okay? I don't care if they're in group one or not, just one in the last shell. Hydrogen, lithium, sodium, and potassium. Look at these numbers, people. Interesting things happening. What do you see? The values are going down. Let's try another one. Let's say I want to know about noble gases. First, second, third. Wait a minute. Same trend. Values are going down. Maybe ittefaq hoga. Let's try another one. Let's talk about elements with 2 electrons in the last shell. Just 2. 1, 2, 3, and 4. No way. Same trend. Clearly, down the group, these values are decreasing. क्यों होगा ऐसा? अगर वैल्यू कम हो रही है, इसका मतलब है अट्रैक्शन कम हो रही है. ऐसा क्यों हो रहा है? न्यूक्लियर चार्ज तो बढ़ रहा है. We are getting greater nuclear charges. Then definitely this is not a significant factor down the group, because you're right. Radius is increasing rapidly, and with that you're getting a lot of electrons as well, which means shielding is also increasing rapidly. If shielding increases, repulsion increases, attraction decreases. With attraction decreasing, ionization energy goes down. Attraction कम है, मुझे उसको तोड़ने के लिए एनर्जी भी कम चाहिए. Radius ज़्यादा हो रहा है, attraction कम हो रही है. कम attraction, कम ionization energy required to break that. And the data tells me that effective nuclear charge कुछ भी नहीं कर पा रहा है, because it's unable to counter these two things. And there you go. They clearly see what happens down the group, what happens across a period, and they don't even know about shells yet. Amazing stuff happening. Periodic table is probably the smartest thing any person has ever thought of. कमाल के ट्रेंड्स हैं. हमें 3 बातें पता लगी. पहली बात, प्रोटॉन इलेक्ट्रॉन सेम होते हैं, एक न्यूट्रल एटम है. दूसरी बात, डाउन द ग्रुप आयनेशन एनर्जी डिक्रीज करती है बिकॉज शेल साइज बढ़ता है, शील्डिंग बढ़ती है, radius बढ़ता है, which both contribute to a weaker attraction. But the effective nuclear charge is not that important or not that significant because the value still goes down. Across a period, however, the story is different. Across a period, shielding isn't that important because effective nuclear charge is there, radius is constantly going down, which means attraction is going to be higher. With higher attraction comes a greater ionization energy. ठीक है, समझ आ गया?
Sir.
Yeah.
Sir, so basically, effective nuclear charge is increasing like both trends, like even if across
Yes.
the period and like down the group.
Yes, it is.
Thank you.
But its impact is different across a period. Its impact is much more pronounced across a period, but not so much down the group because there's other things that are outweighing it.
Yep, got it. Thank you.
Now, there was this another guy. He was like, maybe there's other trends in there. So here's what they did. He started some maths. So उसने कहा देखें, let's see how the values change. उसने कहा देखते हैं. Down the group जा रहा हूं and I want to know how the values change. Okay, so down the group 1 में a really big jump. Group 2 में it's doubled but not so strong jump, not so significant. But the significant jump, what's happening here? Sorry. But there is a significant jump here. Okay. Group 3, let's see. What? A significant jump here? Okay, maybe this is just इत्तेफाक की बात है, ऐसा हो नहीं सकता. Let's try another one. Let's say we go to sodium. Okay, so a significant jump here. Wait, what? A significant jump on the second one? And a significant jump again like this? Something's happening here. There is something fishy going on. In both of these cases, where the lithium and sodium को अगर मैं देखूं, तो lithium में ये value और sodium में ये value, first one, they are much smaller than the second value in both of them. So somehow these are in one category and these electrons are in some other category. मतलब ये hundreds में और वो thousands में jumps हैं, बहुत बड़े jumps हैं. They're in a totally different level of energy. Let me try again. हंड्रेड्स में कोई बहुत ज्यादा फर्क नहीं है, वो बिग जंप। भाई ये इनका लेवल ही कुछ और है। सेम थिंग है। लेट्स ट्राई दिस थर्ड वन। ओके, एंड ओवर हियर अगेन सिमिलर ट्रेंड्स, इतना ज्यादा फर्क नहीं है, बट दिस इज अ होल न्यू लेवल ऑफ एनर्जी। Let's just call this thing energy level. That's what they did. They said that these are at one level of energy, the first two in group two, and the next are at other level of energy. And that's how we got the name energy level or shell. And turns out, interestingly, if you look at more values, अभी तो ये सिर्फ 4 values हैं, अगर आप 5, 6, 10, 8 values को देखो, you will see the big jump always comes after, पहली jump आती है group number के बाद. So group 1 है ना, तो पहली jump after the first आएगी. And this trend continues है. Group 2 है, पहली jump second के बाद आएगी. Mind you, these are people who have no idea what shells are. In the third one, पहली jump 3 के बाद आती है. In the fourth one, पहली jump fourth के बाद आती है. In the fifth one, fifth के बाद आती है. Sixth के बाद आती है. And you get it. But then अगली jump जो आती है ना, वो 8 के बाद आती है. और वो insane jump होती है. मतलब जैसे ये 100 से 10,000 में गया ना, वो 10,000 से 100,000 में निकल जाता है. Big jumps. A completely different level. A whole new game. Maths में ना, there's a thing that talks about these jumps. जो levels होते हैं ना, like हम counting कैसे सीखते हैं? हम कहते हैं यूनिट है, फिर 10 है, फिर 100 है, फिर 1000 है, फिर 10,000 है, फिर 100,000 है. इस तरह से हम चलते हैं. मतलब इकाई, दहाई, सैकड़ा, हजार, 10,000, लाख, इस तरह से चलते हैं हम लोग. मैथ्स में देयर इज अ फंक्शन दैट टेक्स केयर ऑफ इट. अगर आपने सिर्फ देखना है ना कि इस चीज में यूनिट्स हैं, आपने सिर्फ देखना है इसके टेंस हैं, यू जस्ट वांट टू लुक एट द लार्जेस्ट लेवल है, तो उस चीज को मैथ में हम बोलते हैं लॉग. लॉग गेट्स रिड ऑफ एवरीथिंग दैट्स स्मॉल, दैट्स इनसिग्निफिकेंट, ओनली लुक्स एट द हाईएस्ट थिंग. लॉग ये करता है ये. तो हम उन्होंने केमिस्ट्री वालों ने वो चूंकि प्लस माइनस कर रहे थे, मैथ से उनको बड़ा लगाव था, उन्होंने लॉग अप्लाई करके देखा. उन्होंने कहा देखो यार, पहला है, दूसरा है, इनका जंप है इन वन, लेट्स से ग्रुप 2, बट जो अगला है ना उसका जंप बहुत ही बड़ा है. उसके बाद 8 का शेल, 8 का इतना जंप नहीं है, फिर उसके बाद फिर बहुत बड़ा जंप है. तो उन्होंने कहा एक काम करते हैं, वी जस्ट लुक एट के पहला जो है ना वो हंड्रेड्स में है, पहले दोनों, अगले दोनों, अगले 8 10,000 में, उससे अगले 8 100,000 में. सो हम उनको एक लेवल पे ले आते हैं. सो टर्न्स आउट व्हेन दे डिड दैट, तो ग्रुप 2 का हमेशा ग्राफ ऐसे बन रहा था. मतलब यहां पे नंबर ऑफ इलेक्ट्रॉन्स थे और यहां पे एनर्जी रिक्वायर्ड थी और उसका लॉग था. लॉग क्यों? ताकि वो देखना चाह रहे हैं कि सिर्फ हंड्रेड्स बताओ, मुझे 411 में 11 नहीं देखना, मुझे देखना है कि हाँ ये 400 है. मुझे 892 में ये नहीं देखना कि ये 92 है, मुझे देखना है कि ये अराउंड 900 है. अप्रोक्सीमेट वैल्यूज बताओ और यूनिट्स में बताओ. सो व्हेन दे डिड दैट, टर्न्स आउट ग्रुप 2 में हमेशा ये होता था कि पहले दो ऐसे आते थे, अगले 8 ऐसे आते थे, मतलब ऊपर नीचे हो रहे हैं लेकिन एक ही लेवल पे हो रहे हैं, फिर अगले वाले ऐसे आते थे. हमेशा ऐसे होता, 3 डिफरेंट लेवल्स आते थे. दे ट्राइड इट विद ग्रुप 3. हमेशा क्या होता था, पहले 3 एक लेवल पे आते थे, अगले 8 एक लेवल पे आते थे, अगले एक लेवल पे आते थे. दे डिड इट विद ग्रुप 4. एवरी ग्रुप दैट दे डिड इट विद सेम ही होता था. दे सेड देखें, दीज आर लेवल्स ऑफ एनर्जी, लेट्स कॉल देम शेल्स. शेल क्यों? शेल क्या होता है? टर्टल को देखा, उसका शेल होता है, उसके अंदर वो प्रोटेक्टेड होता है. ठीक है, ऐसे ही ये वाले जो है ना, ये आपस में इकट्ठे हैं, प्रोटेक्टेड हैं फ्रॉम द आउटर वंस. ये शील्ड कर रहे हैं न्यूक्लियस को, जो पता नहीं किधर जाके बैठा हुआ. So shell and energy level, the ideas came from there. And there you go. The general trend now becomes कि every time you try to change a level, you have to supply a lot of energy. And for some reason, these shells correspond to the electrons in the shells correspond to the groups in the periodic table. And more than that, it's amazing honestly कि मतलब जो चीज ग्रुप अगर कैल्शियम है ना इट्स इन द फोर्थ रो इन द पीरियोडिक टेबल उसमें 4 लेवल्स होते थे हाइड्रोजन है ना एक लेवल है मैग्नीशियम है 3 लेवल है एंड पीरियोडिक टेबल में भी थर्ड पीरियड में है थर्ड रो में है नजर आ रहा है एनर्जी लेवल हैज अ वेरी स्ट्रॉन्ग कोरिलेशन विद द पीरियड इन द पीरियोडिक टेबल और ग्रुप के साथ भी है ग्रुप 2 में हमेशा सेकंड के बाद बड़ा जंप आ रहा है तो उन्होंने कहा देखें बहुत सिंपल सी बात है कितने लेवल्स हैं ये पीरियड से पता लगेगा और ये जो पहला लेवल है इस पे कितने इलेक्ट्रॉन हैं ये उसके ग्रुप नंबर से पता लगेगा बट देन केम अलोंग अ गाय उसने कहा एक सेकंड आप कह रहे हैं पहला लेवल है बट अगर आप न्यूक्लियस के लिहाज से देखें तो ये तो आखिरी लेवल है क्योंकि ये जो पहला इलेक्ट्रॉन आपने रिमूव किया ये न्यूक्लियस से तो सबसे दूर होगा ना मैं कहा हाँ ये बात तो बिल्कुल ठीक है न्यूक्लियस तो इसको सबसे कम अट्रैक्ट कर रहा था ना so that is why they said oh so this one is the outermost और ये जो जंप्स आ रही है ना these jumps are के attraction का level different हो गया so this is one valence electrons and these are the inner ones and these are the further inner ones और जितने levels हैं हमें उनसे पता लग रहा है कितने shells हैं कितने levels of these attraction are from the nucleus all of it again comes back to attraction and repulsion one level repels the other level so जब आप big jump देखते थे ना वो इस वजह थी क्योंकि ये वाले जो हैं इन तीनों को एक जितनी रिपल्शन हो रही थी इन सबसे सो आउटर मोस्ट को उससे अगले वाला शेल रिपेल करता है उसको उससे अगले वाला शेल रिपेल करता है सो जब आप वो शील्डिंग खत्म करते हैं ना ये शील्डिंग है ये रिपल्शन शील्डिंग है सो जब आप ये शील्डिंग खत्म करते हैं इसका मतलब ये हुआ कि इन सब को निकालते हुए दिस शील्डिंग वाज हेल्पिंग यू आउट एक जितनी रिपल्शन है उनको निकालने में आपको एक जितनी एनर्जी लग रही है रफली बट इन सब की शील्डिंग भी सेम है तो इस वजह से इन सब के भी एक ही जितनी लग रही है और रेडियस भी रफली सेम ही होगा ये एक ही जितने दूर होंगे इस वजह से इनको एक ही जितनी एनर्जी लग रही है और ये भी एक ही जितने दूर होंगे इसलिए एक ही जितनी एनर्जी लग रही है एंड इट ऑल कम्स बैक टू अट्रैक्शन एंड रिपल्शन एंड देन दे केप्ट ऑन डूइंग दिस करते रहे वो मतलब meticulously दे स्टार्टेड ग्राफिंग दीज थिंग्स इनके लॉग्स निकाले इन वैल्यूज को फर्दर देखा तो दे रियलाइज्ड कि there are many patterns in there we will talk about those patterns tomorrow that how do those patterns help us come up with the idea of uh, shells and eventually how the electrons are arranged in there of course it goes a little deeper than that they had to do relativistic effects or kafi kuch unhone, especially for bigger atoms but for the first 20 elements the trends are remarkable honestly like they are amazing और वो नजर आ रहे कि मतलब these are numbers speaking to us कि देखो ये ऐसे ही नहीं है there is a lot going on in there and it all comes down to attraction and the between the nucleus and the outer electron okay and the factors affecting it ये 3 factors हैं at the end of the day and then they started predicting कि अच्छा ग्रुप 7 में हो आप तो ग्रुप 7 में ना 7th के बाद जंप आएगा and they did it with a totally unknown thing और 7th के बाद jump आया that is magic and that's simply power of prediction that we get from the periodic table and from this ionization energy okay clear everybody any questions all right so let me walk you through some exam type questions like exam में वो क्या पूछता है पहली चीज आपसे जो पूछता है वो the first thing you need to be able to explain. And mind you, you all should be able to explain it now. Define the first inertial energy. सोचिए उसका आंसर क्या होगा? I'll tell you the answer in a bit. The first inertial energy is the energy required to remove a mole of electron or 1 mole of electron from the from gaseous atoms. Okay? Okay. Can you write the equation for this? Pick any atom. Let's suppose मैं आपसे कहता हूँ argon की equation लिख के दें. Go on, spend a minute, write the equation. So your equation should have two main things. First of all, it should be argon atoms losing an electron and becoming argon plus 1 ions. And secondly, these should be gases. Okay, now write the second inertial energy of aluminum. If you've written that, you should start with aluminum. Second inertial energy means that you are getting a second charge. That means you'll start with a first charge. It should lose an electron, and there should be gases. So 1 point will be for these, and 1 point will be for the correct states. Okay, next thing that you need to be able to tell. How does the inertial energy decrease or affect? Sorry, how does the inertial energy change across a period? Again, let me use the word examiner will use. They will say describe. So describe how the energy changes, inertial energy changes across a period. So your answer should be it generally increases. You describe it, bas. Reason nahi deni hai. The second word examiner will use is explain. So when they say explain, then you have to give a reason. The effective nuclear charge is higher. The radius is becoming smaller. And the shielding is roughly the same. क्योंकि एक ही level है ना. Now down the group, describe it. Think about it. सोच लिया? Your answer should be it decreases. Generally, it decreases. No reason required. Now the examiner says explain. The moment they say explain or elaborate or give reason or suggest why, ये words हैं उसके. Examiner इस तरह से बात करता है. So जब वो ये कह रहा है, then you have to give a reason. You have to touch upon all the three reasons. It's super important that you touch upon all the reasons. So first of all, effective nuclear charge is increasing, but it's not significant. It's counterweight by two other factors. कौन से? Shielding effect increases because it's getting a different level, a different shell. And the atomic radius increases rapidly, which both of them decrease the attraction. And so it takes less energy to remove the electron. Next thing that they'll ask you about is कि एक ही element के different energy, inertial energies explain करेंगे कैसे होती है. We'll talk about that tomorrow. कि एक ही element को पकड़ लो, argon को पकड़ लो, how does its values change? ये हम कल करेंगे. Then there is a fourth factor that usually comes in. Again, we'll do that tomorrow. It's called a spin of electron and how that takes into account how that affects the attraction and repulsion. And lastly, you need to be able to identify कि if an element has a big jump after the fourth electron or after the fourth inertial energy, if there's a jump between fourth and fifth, which is unlike any other jumps before, that means this must be in group 4 because iske last shell mein 4 electrons. And that is all you need to know for this topic. Thank you so much.